All right, here we go, everybody. So thank you so much for joining today. We greatly appreciate it. We're kicking off the YouTubes, the LinkedIns, the Discord. Man, we're just everywhere, and it's flipping crazy. This is awesome. And like I said, if we have people that come in and they're getting a blank screen, but they're getting in the audio, if everybody can tell them, hey, jump over to YouTube, jump over to LinkedIn. It appears to be working just fine there. It's a bug in the system. So we're ready to rock and roll. So we ended yesterday with kind of a lab and a little bit of a challenge for people. And it's at this point where I just kind of pissed some people off. How many people typed the entire script in? How many people went in and typed the entire like automatic port blocking? You can lie to me. You all can lie to me. That's fine. Yeah, just basically say, yeah, we did the homework that John asked us to do, and I'll trust you. I'll trust you. So I don't want to lie. All right. So I feel bad just a little bit because it's already here. So if I log in as root and I type ls, it's already there. So I have it. Sorry, it's there in the root directory for everyone to play with. But that's not really the point. The point isn't just like knocking out the script and then kicking ass and like, oh, I'm done. No, it's to try to understand what the script is doing, because it's actually really, really, really important to understand what is going on whenever we're creating something like an auto block script. And as soon as an attacker touches that script, it locks that IP address out. So what we're going to do now is we're going to go through this bash script step by step by step, so you know what it's doing, so that you understand the overall risk of doing an automated block script. I like how somebody said, I don't want to lie. And somebody else in the class said, my dog ate my script. Different ends of the spectrum here from people. So first, let's less out the honeyport.sh script right here. And this is the functioning script. But the goal of this isn't like, here's, there you go. No, I want to walk through it. So the magic of this particular script is the IP equals. If you remember, we were talking about how we can make this bigger, enhance. There we go. How we can like set this up as a variable. So we have IP as a variable that we invoke later. So we're creating a variable called IP. We're going to use that variable here in our IP tables rule that drops any connections that are coming into this computer system from the source of that IP address. But look closely. You see this little guy right there? What is that? What is that? I do have my delicious low sodium V8 today. By the way, low sodium V8 still not sponsoring my pay what you can classes. So we're going to keep hammering that until they come around. It's a backtick. That's correct. It's a backtick. Now that backtick is different than a comma. So whenever we're doing a backtick, we're going to wrap that entire line, that netcat, all the way to the other backtick. And we're going to take the output of all of that garbage, and then we're going to assign that to a variable called IP, and then we're going to invoke it. Literally what this thing does is it creates a listener, it greps for any connections that come in with the word received, and then it pulls out the third value, which is the IP address. You can use cut to do this. I used awk in this script just because I'm weird. So it does the exact same thing as doing cut space -d, specifying a delimiter, giving it a space, and then giving it a value of like F3. So it's kind of the same way of doing the same thing. By the way, whenever you're working with Linux computer people, you get into these petty arguments like, well, if you did it with awk, it would be better. If you did it with sed, it would be better. If you did it with cut, it would be better. I don't care generally, unless we're doing things that are very high performance. So really, whatever works, great. That's awesome. I've had people that recreated this entire thing in Python. That's fantastic as well. Honestly, if it works for you, if it floats your boat, if it tickles your pickle, then you do it that way, whether it's in Python or Perl or anything. And if you have anybody that gives you shit about how you're actually doing things, feel free to ignore those people. And more importantly, don't party with them when you're at conferences like DEF CON. So let's start taking this apart. So the first thing that we're going to do is we're going to open up a netcat listener on port 1025. I'm going to take this thing apart piece by piece by piece so we can see what it is actually doing. Now I'm going to open up another prompt. I'm going to paste that in, and then I'm going to connect to it. All right. So anytime you're working with scripting or coding, you don't want to look at it as like, I'm going to write this amazing program that's going to solve all the problems of computer security. No, you take it piece by piece by piece and understand which each of the different piece parts do. And then you assemble them like Voltron or some episodes of the GoBots, which has been completely ignored for the transforming robot like things. Like no one talks about GoBots anymore, but I am, because you remember GoBots also had like a Voltron thing. They were kind of in there in the game with Transformers, but GoBots were great. Actually, I think GoBots were like Transformers for poor kids because they were small, but I digress, which is what I do here. So I'm going to split my screen here real quick. We're going to split the tab. So we have two of them back to back. So I'm going to go netcat to 127.0.0.1, and I'm going to connect to that port, that 1025, and see if we can get a connection. So whenever I make a connection, you can see it says connection from 127.0.0.1, the source port received. Excellent. So the thing I want is I do not want the line that says listening. I don't care about that one. I care about connection from, this line that says connection from and then received. All right. So we want to pipe all of that through. We want to get to the point where we can grep out the string that has the word received in it. So I'm going to kill this really quick, and we're going to go back to our script and we're going to step through it a little bit more. Now, if you remember yesterday, I was talking about how Netcat puts all of its messages into standard error. Standard error is represented by a 2. Standard output is represented by a 1. All right. So what we have here is we have duplicated standard output. We have the standard errors getting redirected into standard output, and then we're cleaning up after ourselves and we're putting it into dev null. But that line is going to come out of standard error. It's going to go to standard output, and then it's going to get piped through grep so we can grep the string received. So let's go ahead and grab that whole line. So we copy it, paste it over here. There we go. Now I'm going to run it, and notice it doesn't print out that it's listening. If you look up here, it printed out listening on 0000 family 0 port 1, port 1025. As soon as we are grepping out the string received from the error that is put into standard output, it's not going to print that string because that string does not have the word received in it. However, if I make a connection to that port, it actually prints out that line, and just that line, because that line has the word received in it. Excellent. We are getting there, building it up piece by piece by piece, cleaning it up. Let's go to the next piece. Okay, I got to go over here to the other tab. There we go. All right, now I'm going to do the awk statement, which is going to basically print out the third value because it says connection from IP address. We want to grab that IP address. And this print awk statement, or this awk print statement, is literally just specifying delimiters as a space, and it's printing out the third value. So let's see if that works, because that's all we want. I don't want that entire string. I just want the IP address in that string. All right. So I go ahead, I start that. Now I remake my connection. Now notice it hasn't printed anything. This is kind of a bit of a weird quinky dink. The reason why it hasn't printed anything is I haven't closed the connection. I've got a half open connection. So now if I kill this connection, then it prints out the IP address. So it prints out the IP address at the termination of the connection. Now I've got the IP address. Now, what happens next is we assign it to a variable called IP. I can do that here. Just taking it piece by piece by piece. There we go. Go like this, make that connection. Oh, it helps if I start the listener over here. So now I make the connection, kill the connection, and notice it didn't print anything. It didn't print anything at all because instead of it being displayed to my screen, it saved it to a variable. So now if I do echo $IP, it prints absolutely nothing. I don't know why it did that. That's kind of weird. Never mind the man behind the curtain. There we go. That's really flipping weird. That should work. Everyone's giving me thumbs up. I'm just happy to see that you have problems with this. So Oh, use the other terminal. That's right. Thank you. Echo $IP. There is our value. Thank you. You're absolutely right. That was my problem. That's one of the things I love about having 87 people watch me while I type and screw up live. They help me find my mistakes, but you're absolutely right. I was in the wrong terminal. So echo $IP and bam, we now have that IP address. So now we string this whole nightmare together, but I'm going to do this a little bit differently. I'm going to close out this. And now what we're going to do is we're going to run honeyport.sh. All right, now it's started. So now I want to show you why you don't have to be worried about this script actually killing legitimate connections coming into your environment. I'm going to get my IP address for my Linux system here. I have config. Oh, that's so ugly. Let's do this instead. Let's open up a brand spanking new one that's the right size. Run IF config, and I have my IP address. Now, I'm going to do a couple of different types of Nmap scans, but I'm going to run them from my Windows computer system. So I'm going to run Nmap, and I'm just going to do a straight SYN scan against my Linux IP address. Now, when I do that, you see that that port is open, but take a look. Oh my God, I can't believe I did that. I closed it. No! It's one of those mornings. There we go. We got it running again. But it says that it's open, but if I keep running it, it continues to say that that port is open. So if I rerun it again, it's open. If I rerun it again, it says it's open. Does that mean my script isn't working? So this is something that's really important. Netcat doesn't log a connection unless there's a full established connection made. Unless there's like a full established connection made. So if I were to do this scan and I were to provide decoys to try to block out the IP address for Google, still isn't working, right? So I specified a decoy IP address right here. And it still says that the port is open, but it hasn't blocked out anything. Anybody know why? Got some people coming through talking about this stuff. Anybody know why? The reason why, once again, is because Netcat doesn't log the connection until there's a full established connection. So I want to show you two things in quick succession. The first thing I want to do is I want to show you what happens if you try to do a connect scan with a decoy. So let's do minus, instead of S, we're going to do T. So that means it's going to do a full connect scan. Instead of just a SYN scan, it's going to completely try to complete the TCP IP three-way handshake. But notice that Nmap gave me an error. It gave me an error. It said, you have specified some options that require raw socket. These options will not be honored for a TCP connect scan. Specifically, the option that it flipped out about was the decoy. You cannot spoof a fully established connection from another IP address. I mean, technically you can, but it's really, really flipping hard. And it's how do I put this? Does anybody know how many possible values there are for sequence numbers in the TCP IP header? Anyone know? Got to have some people here, some packet heads. No, 65,536 would be the number of ports. How many sequence numbers are there? Noob for Life said 1 billion. More. It's more than 1 billion. I'll give you a hint. It's a 32-bit number. How many possible values are there in a 32-bit number? Yeah, we got some people coming. Over 9,000. It is, in fact, over 9,000. If it's a 32-bit number, it's 4.2 billion possible values and change. All right. So whenever you're trying to spoof a fully established connection, you have to guess what the sequence number is for the acknowledgement packet coming back. And you have to guess that sequence number in less than like half a second. Out of 4.2 billion possible values, you have to guess the right one to spoof that connection within half a second. It's kind of like an IP address, right? Yeah. So we have sequence numbers, like 32-bit number. IP address is a 32-bit number as well for IPv4. So when we're doing this, it's not going to allow us to spoof that IP address of 8.8.8.8. And it's not going to allow us to do that because it requires the full TCP/IP three-way handshake. Also, as soon as we went to a full connect scan, Netcat is now blocking this particular IP address. So I like to walk through this lab because we now are looking at it from the terms of like, you can implement this effing everywhere in your environment. I don't recommend that you set it up on like every single system, but let's say one system per subnet. So it has some alerting. If somebody is scanning that subnet, it'll generate an alert, and then you can kick these log files out to a logging server, and you can automatically ban the IP address that's doing port scanning. Now, somebody mentioned yesterday, quite astutely, by the way, they mentioned yesterday that you really want to be careful with allow listing your vulnerability assessment scanners. And all you need to do is create a rule in your firewall rules that's before this rule that allows any and all traffic from that IP address that's scanning, because in your firewall, the rules are basically handled sequentially. So if you have an allow rule that exists for your vulnerability assessment scanner, it's going to be just fine. Not going to have any problems. Anything that comes after that, though, is going to be blocked. If you use a decoy in the scan, does it block the IP address specified in the decoy? It does not. So once again, if we go back here and we specify a decoy, if I specify a decoy here with a SYN scan, because you can't do a decoy, you can't spoof with a full connect scan. You can only do it with a SYN scan, and it's still not going to get any ports back, but it's not blocking the decoy IP address. So I can put in as many decoy IP addresses, and Netcat's never going to block them because they never establish the fully established TCP IP three-way handshake at all, because you can't if you're spoofing an IP address. So hopefully that makes sense to people. And this just is like the super fun thing that you can do in your environment that really will frustrate a pen tester or an attacker. You set this up around the inside of your environment, a number of different places. You can set it up on the outside of your environment. And what you do whenever you're running this is you wipe out all of the script kiddies that are out there. All right. You're going to have people that just try to hit you with a basic port scan. They're done. Like, you're wiping them off the face of the planet. They're not going to be a problem. And there's some really amazing things that happen with this. The first thing that happens is it cleans up the signal to noise ratio in your environment for security. What are the alerts that you're going to hunt on? What are the alerts that you're not going to hunt on? This is going to get rid of the low-hanging fruit skidiots that really aren't going to get into your environment, but they will generate a white noise that becomes problematic. One of the companies that implemented this, and this is a long, long, long time ago, is Apple Computers. Apple implemented this on the outside of their environment, and if you scan IP space of Apple, it'll automatically deny list you if it sees you running a port scan. And they deny list thousands and thousands of IP addresses every single day. That brings me to the next added bonus of doing this. One of the things that Apple found out when they did this that was kind of a surprise is there were so many different attackers coming in, and all of them were getting logged, that it just this one rule that they put in their environment, it saved them over $100,000 a month in log costs, because all of those attack IP addresses were wiped out. They didn't make it to their intrusion detection system. They didn't need to log anything else from those IP addresses at all. So very powerful stuff. All right. So You can run this from your system. You can take the script, you can move it over to other Linux computer systems, super easy to do. Now, this is the Windows version of this script. This is a batch script, not a bash script, a batch script that you can run that'll do the exact same thing. You run this script in the same directory where you have netcat, and the exact same thing happens on Windows. And if you look at the overall structure of this, it pretty much is the same thing. We can do 4F for output of a file. It says delimiters equals open bracket. What does that mean for delimiters in batch scripting? Anyone know? It's a little bit crazy. So what that means in batch scripting is it means open bracket, close bracket, and space. Look, I'm just going to be honest with you. It reads delimiters equals open bracket, close bracket, space, and then there's a space. Why is it like that? I don't know. I guess Bill Gates hates us. Whatever. Specifying the number of tokens we're expecting to receive. We're taking that value right here and we're assigning it to a variable called I. And then we say in, and then we still have the backticks. Netcat listen on port, that's not a 1, that's an L. Port 3333, don't resolve any names, be verbose. We still have standard error sent to standard output. We take that output, we find the string from, and then we set the IP address equal to the variable I. Then we run a firewall rule, netshadv firewall, add rule name, delete, direction in, remote IP address is the variable we establish here, local port any, protocols TCP block. So this is wild because it works. One of the organizations I did some work with a long time ago, they had a kind of an adversarial pen test that was dropped on their organization. And what I mean by that is so what happened was they got a new CEO, and the CEO noticed that they had a security operations center, network operations center in the East Coast and another one in the West Coast. Now, why would you have two network operations centers for a company? Why would you just not have one? Why would you have an East Coast and a West Coast NOC? Jesse, Atina, Ethereal, redundancy, right? Everybody knows that. It's just redundancy. That's what we're after, coverage. CEO came in and said, hey, we're losing a lot of money having two network operation centers. This seems like a waste. And I read the book by Jack Welch from the gut. And I decide I want to drive my company into the ground from reading that book, because Jack did a great job of doing that with General Electric. And the people from Boeing listened. It wasn't actually the people from Boeing, it was people from McDonnell Douglas, but that's a whole nother story. And we're going to hold tryouts. And he hired a pen testing firm to come in and look at the East Coast NOC and the West Coast NOC to see which one was the tidiest. And the one that had the better security profile was going to keep their jobs, and they were going to shut down that other NOC that didn't do so well. So it's an East Coast, West Coast rivalry, once again, turning Nebraska into a battle zone, because Nebraska is a battlefield. And my friend called me up. He said, I don't want to lose my job. Do you have any ideas? We implemented this in his environment. Pen tester shows up, runs a port scan, SYN scan, sees lots of systems, lots of ports open, gets super duper excited about the fact that there's lots of ports open. And then they run a full vulnerability assessment scan against the environment, which trips these honeypots all over the place. And the entire network goes dark to the pen tester. Now, what do you think goes through a pen tester's head when an entire network just like evaporates and goes dark? Any ideas, folks? Yeah. Oh shit, I broke something. Yeah, I've messed up. Now there's some people, it's kind of funny how there's some people that are like, well, clearly the network's deny listing me. That's not what a pen tester thinks. Like seriously, the first thing that a pen tester is going to think is I broke something. So they went to my friend and they said, hey, is the network working? My friend's like, network seems to be just fine. Carry on. It took the pen tester an entire day to figure out that these deny lists were popping up and automatically shunning them. And then they demanded that my friend remove all of these deny lists and all this stuff. My friend said, hey, do me a favor, everything after this point in the report, can you note that any vulnerability that you discovered after this point, you discovered because we allow listed your IP address in the entire environment. Of course, the pen tester was like, yeah, sure, we'll put that in the report. Totally didn't make it in the report, by the way. They had to have it added. So yes, this works. Yes, this is going to really anger pen testers and hackers. Yes, it's a good feeling. It's like whenever I teach this class and people hire Black Hills Information Security and people implement these things in their environments. And then my pen testers come to me crying, saying, how could you have taught them how to stop us from pen testing them? I say, dear pen testers, send me your tears. They make the best wine. All right, so what does this buy you? Well, it gives you visibility, first and foremost, right? Current intrusion detection, intrusion prevention technologies, they will fail at detecting attackers communicating over standard ports. If they're doing things over SSH and SMB, a lot of the different tools will just miss this. They will just miss it. IDS and IPS are great. I think that they're fantastic, but they're blind against 0 days. They're blind against somebody using legitimate protocols in the environment. They're blind for many port scans as well. The other thing that this buys you is a wonderful level of flexibility. You can run this on Windows. You can run this on Linux, run it in PowerShell, Python, Ruby on Rails. It is fantastic. It is also, what it does is it makes you effective to post-exploitation and air-gapped DoD networks. You see, I had to do this. I was working on a classified program. The unclassified name was Intelligence Community Multi-Acquisition Program, or ICMAP. And we were having a pen test, which is what is done. And I wanted to bring in some security technologies, and they weren't on the low risk and an approved list. So the NSA, they create these lists, or at least they did. They created these lists of software that's low risk and approved to run on classified networks. And it was old, it wasn't up to date, it was janky. So I couldn't bring in the security technologies that I wanted or the versions that I needed to be successful in defending this network. So I actually implemented variations of this on a network, and it shut the pen testers down. That's great. That's part of the reason why we're telling you this, because some of your organizations will say, well, if we want a tool, it's going to take time and money to implement. If you're just sitting down with just you, a command prompt, and a dream, you can hammer this out fairly quickly, because it's not that you're bringing in software. No. What you're bringing in is you're just writing a little script that does these types of blocking activities. That I know that seems like a distinction without a difference, but in classified facilities and in unclass America and corporate America, this is a huge deal, especially if there's a huge change management process that you have to go through to get it to work properly. So what do these buy you in the enterprise? Well, they're easy, right? You don't have to set it up on every single system, but you absolutely could put it on every single subnet as a tripwire. Now, if you're doing this, let me show you something. We have this Honeypot script. So if you want, one of the things that you can do is you can create a rule that's the exact same rule right here. And you can create a rule that instead of jumping it to drop, you can jump it to log first. So the rule, well, you put them both in here. Let me actually edit this real quick. So let's do VIM, honeypots, like that. So you can take that IP tables rule, and then you can duplicate that exact same IP tables rule, and then you can jump it to log, all right? But you have to put it above this rule, okay? So we're going to do this. We're going to log it. And you can even put in a log prefix on this too. So what happens is as soon as somebody trips this, there's going to be a log that's created in var log messages. So you can basically take all of these. Yeah, it's the Ren and Stimpy show. It's log, log, log. It rolls downstairs, bubbles from chairs, runs over your neighbor's dog. It's heavy, it's wood, it's log, log, log. Log, it's log, it's big, it's heavy, it's wood. By the way, the dude that created Ren and Stimpy messed up. Like, we remember watching Ren and Stimpy, and it's like, the person that did this is messed up. And he was. actually. Yes, and that is a squirrel. All right, so we can deal with this. So we can generate these logs, generate these alerts, pick them up, and then we can generate automatic shunning rules in the environment that we can spread around. You might mess with vulnerability assessment scanning. You just create exceptions and you put that log exception up above, not log exception, that IP tables rule above. So if you know your vulnerability scanner, you're going to create a rule, IP tables, you're going to create a rule to the input train, and you're going to go source vulnerability scanner jump accept, and it's going to allow it to jump and bypass any of these like rules and any of these things out there as well. So really, really super cool out there. It's possible, once again, very, very incredibly unlikely that somebody may be able to guess a sequence number. But if somebody can come up with a way that successfully guesses sequence numbers, it's not a vulnerability in the script, it's a vulnerability in the sequence numbers. The only real attack I know that's public that they used sequence number prediction was Kevin Mitnick attacking Satomu Shimomura's computer system way back in the late 90s. If you want to read about it, you can read about it in a book called Takedown, The Pursuit and Capture of Kevin Mitnick. But Satomu talks about how Kevin Mitnick used this and was able to send commands to systems to take them over. Yep, we're going to miss Kevin. And yeah, but that vulnerability was patched. It was actually fixed a long, long, long time ago. Right. But let's say you want more. The idea of just blocking an IP address is kind of cool, admittedly, much like this amazing Rekka hat that you can totally get in the Spearfish General Store. Do you see how I worked that advertising in there? All right. So let's say that you want to do more. You don't want to just block the bad person. You want to destroy their life. Like, it's not just like, oh, well, we're blocked, let's move on. You want to waste their time. You want to like just get them so pissed off and enraged that they pee themselves, maybe. I don't know what hackers do when they get really, really angry. I just kind of run with it. All right. So what we're going to do is we're going to up the ante on this one. And this is going to bring us into the next lab, which is port spoof. See, port spoof does something completely different. All right. Instead of blocking the IP address to the attacker, we're going to create a smoke screen that's an absolute nightmare for the attacker on a wide variety of reasons. See, instead of just blocking the IP address, what would happen if we said every port was open on a computer system? Nay, what if we could go further and we could make it so every single port has a quote unquote valid service behind it? What would that do to the attacker? One of the things that it does with the attacker is it really will confuse them insofar as what is legitimate services and what is illegitimate services on this particular computer system. And that's okay. The other thing it's going to do is it's going to greatly increase the total amount of time that it's going to take for the attacker to even complete a basic port scan against your environment. And that's going to be the main question. Like, how long will it take for an attacker to run a port scan against a single IP address running port spoof? Because this is what it looks like to the attacker. Port 1, open. It's running POP3, and it's running an Adora internet mail server. Port 2 is a honeypot. Well done, Nmap. Well done. You caught that one. But port 3 is SMTP. It's postfix. Port 4 is SSH on protocol 7. Port 5 is X11. Port 6 is IMAP. Port 7 is FTP from a Sambar FTP server. Port 8, no effing clue what that actually is. Port 9 is a web server that's a Cisco VPN concentrator running an HTTP config. Ooh, awesome. Now, like I said, this in and of itself, cool. But the best part about it is it's going to take the attacker many hours to run and complete port scan against one IP address that's running port spoof. And that brings us to the lab where we're going to do this. The name of the lab is, coincidentally enough, port spoof. So gives you where port spoof exists, usage information, where it's installed. It's installed in user local bin port spoof. Gives you the config, gives us basic usage. We go down to the example. You become root. You run an IP tables rule. I'm going to talk about what this IP tables rule does in a little bit, but basically it creates a range of ports, 1 to 65,535, jumps them to redirect to port 4444. It's going to basically route everything to the port that port spoof is listening on. Then you're going to run port spoof, you run Nmap, you're going to see every port is open. That's pretty cool. If we try to identify what those services are, they all come back with the service name of TCP wrapped. Curiouser and curiouser. Let's go deeper and let's take more drugs. So if we do that, if we run a full version scan after we kick off port spoof with a signatures file, now all the ports come back with real services, real names, and any of the services that it doesn't know, Nmap's going to print that out and say, I don't know what the hell this is, and let me know. And then we're going to clean it up. All right, everybody. So this is going to be the lab. This lab takes about 20 minutes. So with this lab and the break, it's going to take us a full 30 minutes, 20 minutes for lab, 10 minutes for the break. We will resume at 10 after, plus a little bit more time, but we'll resume at 10 after. So with that, everybody, let's get rolling and let's kick out the jams, everybody. And we are back. Let's do this. All right, so let's walk through this lab. Like I said, I really, really, really like this lab because this is one of those things that honestly, you don't need to get permission. You don't have to worry about warrants or legalities or any of those things because you're above the law. No, I'm joking. It's not like, it's annoyance, right? We're not trying to get attribution. We're not attacking the attacker. We're not doing any of that. We're just messing with the attacker's day, making their life absolutely miserable. And that's a good thing, right? This doesn't need your attorneys. This doesn't need a bunch of people getting involved. It's just some good old-fashioned, straight up fire alarms going off in my building right now. All right, so we're going to go ahead and we're going to start this particular lab going. The first thing I'm going to do is I am going to clear my firewall rules. ADHD is the password, and I'm going to do IP tables -F, flush out the IP tables. And now we're going to create the, well, I'm already ripped. We're going to create the IP tables rule that reroutes all the traffic to port 4444. All right, so now this gets up some interesting questions that I saw pop up during the lab that I wanted to address now. One of them was, what happens if I want to keep SSH running on this system? Well, if you look at this rule, it says destination port is between. So the colon is a range. We have range of colon options. So we can do 1:65535. So that means between 1 and 65,535, reroute all of that traffic to ports 4444. If we wanted to work around port 22, we could do that where we could do one rule, the exact same, but instead of doing it from 1 to 65,535, we would do it 1 to port 21. And then we would create another rule that's from 23 to port 65,535. So you can kind of step around the actual legit ports on the system for this. So that's one way that you can actually do it. Now, I would recommend, if you do it that way, still run fail to ban to basically block those password sprays that will inevitably hit your SSH server as well. But we can work around that by creating rules by using that colon separator and making it work. This rule only has 1 colon. It's of no use to me. But you can do 2 colons or 3 colons or 4 colons. It just depends on how many colons you actually need to actually get these rules working appropriately. So I've got that running. Now what I'm going to do is I'm going to fire up port spoof, copy it and paste it. And it's just straight up, no cool trick at all, port spoof stuff at all. It's just going to say that that port is open on the computer system. So I'm going to get my IP address from my Linux computer system because I didn't follow instructions. And my IP address is 172.21.251.176. I'm going to open up a command prompt on my Windows system, and we're going to let the nmapping begin. I'm going to nmap and we're going to put in the ports 1 to 10 on our Linux computer system. Let me type in, that was not what I wanted. Got too many copy and paste options. There we go. And now it's going to come back and it's going to say that all of these, I did an Nmap, but there you go. You can see that it says that these 10 ports are open. Now, when Nmap comes back and it says that the ports are open, it's like we got TCP mux, compress net, unknown, RJE, echo. It's just pulling these services out of its butt. It's not actually like checking the service, looking into the service, fingerprinting the service. It's just guessing that based on the port number, that's what the service is. For us to find out what is actually going on, we can rerun our Nmap scan and we can run it like SV. Now, this is going to take a few moments for it to work properly. But we're going to say run a service scan against those ports and come back and tell me what those ports are. And it says they're all TCP wrapped. And the reason for this is there's nothing coming back. As it tries to interrogate those ports, the only thing it's getting is a SYNAC back from those ports. Nothing else is going on. So now we want to rerun port spoof, but we want port spoof to be a little bit smarter. We're going to have port spoof execute, but now it's going to give a fingerprints file. So it's going to spoof those ports with actual signatures of a random collection of different services. So we type in the clipboard text, kick out the jams, and now we're going to rerun our scan. Now, something is going to be different. Go. So now we have the scan running, and this is the part where I tap dance for the next roughly 1 minute. Because what Nmap is doing is it's identifying that those ports are in fact open, which is great. But the problem with those ports being open is now it's got a whole bunch of really weird service data coming back into it. So your problem is you're running Nmap from yourself. So you need to run Nmap from a remote terminal like I am from a Windows computer system. So port spoof runs on your Linux system and Nmap runs on your Windows computer system. But after a series of moments, and in this situation, it, let's see, it took, how long did it take? Go down to the bottom. And it took 32 seconds in this example for Nmap to scan this particular system. So how long did it take for it to scan your systems, everybody? Was it 32 seconds? Was it a minute? How long did it take? Javi's typing. 10 seconds. 30 seconds-ish. We're getting some variance on this with the services. All right, so if it takes 30 seconds to scan your Linux computer system running port spoof from the direct connected VM, how long will it take to scan 65,536 ports? So if it takes half a minute to scan 10 ports, how long is it going to take to scan 65,536 ports? Anybody know? Let's do some math, everybody. It'd be shorter to crack my brother's password. I think it takes roughly a day, right? So you take 65,536. You divide that by 10, batches of 10, and then you times that by 30, and that's 30 seconds. That'll give you the total number of seconds. Too early for math. I don't know. It's 11:17 here. It's mathin' time, right? So if we're looking at this from a scanning perspective, it's going to take a really, really long time. And it isn't even a GPU option. It's not something that could be handled appropriately with GPU. You could try to use something like mass scan to scan it, but that would just tell you what ports are open. But to truly identify what the services are and possibly what vulnerabilities those services are running, you're now talking days to run a scan against one IP address. And I want to show you what that looks like whenever it's actually running on our Linux system here. I did CLS in my Discord server. So now instead of running it from port 1 to, let's say, 10, now I can do 65,535, kick it out, and wait. See, there's a problem here. There's actually a couple of problems here. According to the PCI ASV standard for PCI DSS, which TCP ports are you supposed to scan for a valid PCI pen test? Anyone? What systems would you want to run this on? Critical systems, high value? No, you only have to do one per subnet. Just one per subnet. So what ports are we supposed to scan for TCP for PCI DSS? For PCI? Taking a guess. Good a guess. Noob for Life nailed it. All the ports. According to the PCI DSS, especially for ASV and pen testing, you have to scan all 65,536 ports. All of them. Now, this brings us to the issue at hand. I'm currently running an Nmap scan against 65,536 open ports, and all of them are coming back live. Take a look at my Nmap result. If I hit spacebar, Nmap comes back and it says, I've done a minute 20. There's 0 hosts completed. 1 is up. 1 is running a service scan. It's at 0.8% done. Like, what ports are open? What ports are closed? How far is it? It's 8%. What is coming back? See, any vulnerability assessment scanner or a port scanner is really, really, really horrible to identify at what phase of the scanning is it? Like what ports and what services has it completely scanned? Which ones has it not? Just sits here and mocks you mercilessly. Are you guys familiar with the sunk cost fallacy? What is the sunk cost fallacy? So the sunk cost fallacy is the more I put effort into something, the more I'm going to continue to do that thing. Because I've already put so much time into it, it would really suck if I quit and then I'd have to start all over again because it's going to waste all of the time that I've already put into it. So when you're running a scan, a lot of testers and pen testers and hackers will sit and look at this and go like, what the hell? Like, what's going on here? Like, oh, I can't shut it off now because if I kill this scan, I have to start over. And all of the effort that I just put in is wasted. So most hackers won't. They're just going to sit and wait. Also, it goes back to the auditors. Open ports on a PCI DSS box is bad. I wouldn't put it on the PCI DSS box. I would put this on a network with the PCI DSS box. So that way, whenever the auditor shows up and they run their scan, it's going to completely nuke their scan. And the beautiful thing about it is there's no vulnerabilities in this. So they can't look at it and say, well, we've got a series of findings, because odds are their scan never completed in the time that was allotted for it. So now we're going back to detection time plus reaction time must be less than the amount of time it takes to attack. What just happened to our attack time? It went to the moon. So good luck trying to complete your scan. See, once again, does this look hard? Does this look like we really, really need to get lawyers involved? Does this look like we have to spend $150,000 on deception technologies in an environment to set this up? Hell to the no, this works. It works really well, and it doesn't require a lot of crazy overhead to make it work appropriately. All right. So when we're running honeypots, you can run this in a variety of different places. It doesn't have to be on every single host. It doesn't have to be like on every single service. You just need to drop it in a handful of places. And that's going to be enough to slow down or completely obfuscate an attacker's attempts at trying to break into your environment. The next lab, because that's all we do now, is just, this is our life. This is it, everybody. I'm sorry. It's just lots of hands-on labs. But I have something special coming up for you at the top of the hour. You're going to meet Ben and Joe, the people that created the wireless labs for the wireless class that were coming up. But they have something else special for you. Because at Anti-Siphon, every morning we get up, we say, does this in fact suck at capitalism? And yes, everyone says, John, it does in fact suck at capitalism. Is it good? And they're like, yes, sir, it is good that it sucks at capitalism. Could we make it suck a little more? And they're like, absolutely, we could make it suck a little more at capitalism. So we have a little bit more of crappy capitalism coming up at the top of the hour. We're going to break you off with a little bit of preview of the remix. Ah, crap, I just quoted R. Kelly. The only thing that'd be worse is if I quoted Drake, or would that be about the same thing? I don't know. At this particular time, it seems like it's about neck and neck between those two. But the next tool we're going to talk about is Cowrie. All right. So with Cowrie, it's different. We're not creating a port that blocks. We're not creating a smoke screen of a bunch of ports to waste the attacker's time. We're actually creating a legit service that the attacker can interact with to mess with their lives. This is not a much better. This is just an extension of the time wasting activities that you can throw at an attacker because it creates a full SSH service for the attacker to waste their time on. This is from a real IR engagement. We were running Cowrie in an environment in one of our customers, and it pops and it goes through these things. And we got etc and initd IP tables stopped. They're shutting off the firewall rules, changing the permissions of a number of different commands. It's killing a previous version of the malware. It's deleting a previous version of the malware. It's downloading a new version of the malware from this IP address, 119.1.109.43, and on port 443, pulling that down, and then it's executing it. So we saw this on the outside of a customer's environment, which was, I'm going to admit, pretty flipping cool. But if we're looking at this from a threat intel perspective, we now knew that we had to go look and see, were there any outbound connections to 119.1.109.43. If we saw any outbound connections from any internal systems, we knew that system was compromised with a high level of confidence, number one. Number two, we also knew that the malware was Linux time, so we were able to go through the entire environment and see if there was any indications of Linux time running. We found an additional couple of systems that had that backdoor running on it. This is what I'm talking about with threat intelligence. This isn't something that happened against somebody else's network a month or a year ago. This is something that's happening on your network right now. Threat intelligence of the now. I like to live in the now, baby. So we're looking at threat intel in the organization. So when you're running this, you want to collect these commands to find out what the bad person is up to. What are their IP addresses? What is their malware? What is their backdoor? Are they just DOS booters? Are they after certain files? What is the name of their other IP addresses where they're downloading additional backdoors? Are they attempting to use valid user IDs and IP addresses? In the lab, if you want to log in to Cowrie, just write this down. The password, you have to log in as root. And if you log in with a password of like 123456, it's going to let you in. So you can try to log in as root. It's going to let you into the backdoor if you log in as root. But it's also going to capture any failed login attempts for any additional user IDs. So if you see somebody's trying to log in as Bryce, Strand, Mick, Mike, Ethan, Lawrence, Paul, Larry, and those are actual valid accounts in your domain, you're not dealing with just a script kiddie. You're dealing with somebody that is a targeted attacker trying to break into your environment, which, once again, going back to threat intel, this isn't just somebody that's spraying and praying. This is somebody that is actively, directly targeted your organization. It is not automated malware. It is a real human being. It is a real threat actor coming at your organization. And that takes us to the lab, which yet again is going to take us, this one's a little bit longer. It's going to take us an hour or half an hour to get through this lab, and 10 minutes on the other side. We're going to do Cowrie. It's installed in opt Cowrie, basic usage information for the configuration. Example, you're going to CD into the opt Cowrie directory. You're going to run bin Cowrie start. Notice I'm not running as root. If you try to run Cowrie as root, it gets mad at you. You know, mad cow disease. So it's going to get mad if you try to run it as root. You're going to check the status. You're going to make sure that it's running, and then you're going to try to connect to it. If you want to try to connect to it with an actual user account, you would do root at localhost and then just give it a password of 123456. Then you're going to see the logs. Now, there is some like little challenges at the bottom. It says, what happens when you log in with a valid user account in these files? What happens to the sessions? Are there some solid IOCs? It also says the command configurations are in the honeyfs directory. Can you change those? Can you change the SSH fingerprint and things of that nature? So see what you can do to tweak Cowrie, because the defaults, like the SSH fingerprint, light it up like a Christmas tree, that it is in fact a honeypot. So with that, that is the lab. Basically going through it takes like 15 minutes. But if you start trying to answer some of the questions and changing the configuration, it starts adding a little bit more time to the lab. And that's where I want you to start stretching your legs a little bit with this one. So with that, all right, get rolling. We have 30 minutes for the lab, 10 minutes for the break. And at 10 after, we're going to bring in Ben and we're going to bring in Joe, and they're going to show you some of the cool stuff they've been working on at Black Hills Information Security. So get rolling, everybody. We'll see you on the other side. We are back. And I'm getting a lot of echo slap back through. There we go. All right, everybody, welcome back. We have a special treat. Ryan, Uri, do we have Joe ready to go? Ryan, anybody? Where's my support staff? Anyone here? I think I'm gonna have to go. I think I'm gonna have, yeah, the echo was cool. I'm gonna go across the hall and I'm gonna check on Joe. So just give me a second. All right, we've got Jay Boyd we need to promote. He's gonna pop in the question and he's gonna say, hey, promote me. So Jay Boyd at Black Hills InfoSec. What do you mean by OG? Dude, why are the classes led by OGs always cooler than the super expensive, more popular ones? So do we have anyone that's here? Brian, Ryan, Yuri, anybody?
Oh, I'm here, John.
All right, dude. Can we promote Jay Boyd?
In which way?
There's Joe. Joe needs to be unmuted. We're going to get this, guys. There he is. Hey, everybody. It's Joe. Say hi to Joe. Everyone. So, Joe, could you do me a favor? At the control panel for Zoom, there is a button that says share screen. Could you please click that share screen button?
Yes.
All right. Now you're going to click that share screen button and you're going to choose the desktop that has the new Honeypot that we're working on. And then it's going to share your screw modem. Hey, I barely know him. Never get any respect. All right, Joe, do you see it?
I think it's, yeah, there we go.
All right.
Is
now
that visible?
Yeah, there it is. It is now visible. Everybody, Joe is going to show off the new honeypot. Since we're talking about application-specific honeypots, he's going to show off his new honeypot that he is working on, does site cloning and all kinds of super cool things. Joe, when you are ready, sir, please take it away.
All right. So we've been working on this for a little bit now. It's, as John mentioned, it's a honeypot. It's still work in progress, so it's a little bit janky. Doesn't have all the features yet, but has enough that we can kind of demonstrate what it's supposed to do. Its main functionality right now is cloning web pages and resources, and then inserting trackers into those web pages so we can track the activity of an attacker inside of that, like a traditional honeypot. It's not only a honeypot maker, but it's also a management. So we can collect data and then view the data from each honeypot that you've created. And all of your campaigns down here are represented as a little bee. It's all bee themed because honeypots. As the attacker moves through your honeypot or interacts with the cloned web page, they'll collect all sorts of different types of data, such as their location, user agents, all sorts of stuff about them. Down here, we're collecting their inputs as well. So the stuff that they put into different forms that might be on that cloned page and the different sections of that clone area that they're at. Long term, we also want to try and generate graphs and timelines and reporting features from this. It's not a feature we have currently, but down the road, you'll be able to see maybe a map of where they move throughout the website, how long they stayed on each page, where they jumped to. I'll demonstrate a cloning feature here now. So say we wanted to clone facebook.com's login page. We just have to take the link and we could create a new campaign by clicking on the beehive down here. Call this one Facebook login, paste our link in here. And it also has a recursiveness feature. So if we had other links on this web page we wanted to clone, we could clone every link that's on that target and maybe even the links in those links as well. I'm just going to clone one page for this demonstration because that can take a very long time. So it's completed cloning. It's pretty quick. Copy the path into here and we can compare the two. You can see it's an almost identical clone to the original site. And when it clones it, it goes through and hits all those forms. And if I were to put something in here, it's not functional yet, still work in progress, then it would show up down here in this tab. So there's another B that's opened. This one's representative of our Facebook clone. There's no data in here because this isn't a feature we have implemented yet. But as the attacker would use your fake page or interact with it, would generate data on this end. That's pretty much where we're at with it currently. Is there any questions or comments?
Was a question someone asked, is this going to be open source? And the answer to that is yes, it will be open sourced. So yeah, this is a project. Joe, are we allowed to say that we're doing this in conjunction with DSU because you're a student at Dakota State University, or do we need to get approval from them to say that?
As far as I know, we could just say it.
All right. So we got a bunch of interns from Dakota State University, which was an awesome information security university that we've hired some people from. And Joe goes to school there. And yeah, this is going to be done in conjunction with BHIS and DSU as well. So what other questions do you all have? Do we need to get approval to say this thing that I just said? Yes, we do, apparently. I don't think the DSU would sue me. Like at this phase, I don't think they'd be like, well, you were promoting our university and no, you can't do that. They haven't reached that level of like, you know, craziness, not even close. So we're good there. So we got some more questions coming in, Joe. Isn't this the part of the training to add HTML code back to track clone of sites? No, this is something completely different. What we're going to do later with canary tokens is the JavaScript that you can embed into a website that whenever an attacker clones it, you'll be able to track where that cloned website is. So yeah, you can just do this too as well. So, all right. What other questions do we have? All right. Somebody could not remember. Fair enough. Fair enough. Like I said, we've got lots of cool stuff, lots more cool stuff. Actually, is Ben punning the port spoof update off on you, or is he still owning that one?
I think Port Spoof is another intern's project. Donovan Jasper is working on that one.
Yep. So we're taking port spoof and updating it. Even though port spoof still works, which is odd because it hasn't been updated in a really long time, but it was written in C as a binary and it makes it very portable. We're going to update it because there's some really, really cool things that we're going to implement into it. So everybody, a round of applause for Joe. Say thank you. He's doing a lot of cool work. The people at DSU are doing a lot of cool work, trying to, you know, keep these pay what you can projects going. And by the way, I don't know if you're aware of this, but we are going to be changing the name from Pay What You Can to Pay It Forward. So very shortly, the training is going to be Pay It Forward training, because every time someone donates to Anti-Siphon and what we're doing here, it's actually helping more people get into the industry as well. So these are the types of things we do with your dollars. Your dollars make all the difference in the contribution, as we would say at NPR during their revenue drive. So thank you so much, Joe. I appreciate it. And by the way, Joe is the primary mastermind behind the Wi-Fi Forge as well. He's got so much cool stuff that he's working on for us. So once again, a round of applause. And with that, Joe, get out of here. Get back to work, sir. Get back to work.
I'm off. Thanks for having me.
And we will keep rolling. And I'm going to steal the screen share, taking it back again, taking it back. All right, everybody, let's keep rolling. So thank you so much for that. And yeah, I don't know. I know Loki likes it. I don't know what you guys think about that branding for Pay It Forward instead of Pay What You Can. I really want to try to stress that we're trying to really help the community. And when you say pay what you can, it's like, give me money. And it's really not that. It's basically helping the rest of the community is what we are after. And you'll hear more about that as we go through. All right, so let's go through this lab with Cowrie. I need to be logged into my instance, of course, and I think that my VM may have timed out. It still has 1 point some hours remaining. Connecting in. We're now in. All right, so what we're going to do is we're going to close some garbage out that I don't need. And we're just going to open up a standard command prompt. No root, just a standard user command prompt. And we're going to get started. So we're going to cd into the opt Cowrie directory because that's where Cowries live. All right, we're going to paste that in here. Once we are in that directory, we're just going to start it up. Now, behind the scenes, Cowrie is going to be using twist-d as its primary Python library to get it working and get it running. So Cowrie is now fired up. And we can check the status. We can do /bin Cowrie status to make sure it's running appropriately. Like so. It says it is currently running, gives us the process ID. And then if we want to see if the port is actually listening, we can run this lsof command. If you don't know what the lsof list open file command is and what it does, you should seriously think about taking the SOC core skills class from anti-siphon security training, because that's where we talk about such things. And you can see it's listening on port 2222. Now, if I try to log in to this system, just try to do, well, I'm not going to do it this way. I'm going to log in a different terminal. I'm going to open up a second terminal on my Ubuntu system. Going to type in my clipboard text. We make a connection. We type in the password, and I'm going to put in my password here. Try to log in again. Try to log in with a different password. Hit that again, and it should kick me out after the third try. Just gives up. And we're going to see what Cowrie logged in the background, because basically Cowrie is logging all of the authentication attempts, all of the passwords, and all of the commands that are coming into Cowrie, into the opt Cowrie varlog Cowrie directory. If we go in here, you can see that we have the Cowrie log. So I can do tail minus F, not tall, T-A-I-L, minus F Cowrie log, Cowrie.log, like so. And you can see the authentication requests came in. One is ADHD with the password of and another one with a password of blank, and another password with password of as well. All right, so now I want to show you what it looks like when you actually authenticate appropriately to Cowrie, because we tried to log in with a user ADHD. If I try to log in as root at localhost, like so, it asks for a password, and now I just put in a password. And because the root account is like an account that's in existence in the Cowrie config, it's going to allow me to authenticate as root to Cowrie. And it looks like I'm in a real computer system. If I do pwd, it says I'm in the root directory. If I do ifconfig, it says this is the IP address of Cowrie. All of these things work. I can do ID, I can do who am I, and so on. And I'm logged in as root. Now, this is an excellent time waster. In the slide that I showed you a little while ago, I show you these are the types of logs that we capture, right? Where the attacker is trying to run various commands, and I can see where they're trying to pull files back from my computer system. And as I mentioned earlier as well, Cowrie is logging all of these commands: ID, ifconfig, pwd, ls command, who am I. It's really just the super cool honeypot where now I can see all the commands that the attacker is actually using. By the way, we got the Cyber Research DSU program, Cyber Operations. That's the program that's out there. And if you could all do me a favor, go out on Twitter and do a shout out to DSU. Just say, hey, we appreciate what you're doing with the interns at Anti-Siphon. All right. So after a while, the attacker is going to get bored and they're going to exit their terminal because things are just not going to work very well for them. And they're just going to exit out. Now, there's another really cool thing that I want to show you all that I think is really, really super cool. Joe hasn't been working on this one, but we have other people, other interns that have been working on hacking Google for the past couple of years. And it turns out that Google has really weak password complexity in their servers. In fact, I can SSH into root directly. Does anybody know a Google IP address off the top of their head? Anyone? Anyone? What's a Google IP address? 8.8.8. That just happens to be the exact one I'm talking about. So we can SSH in as root as 8.8.8.8. Then, we want SSH as root into that IP address. So let's go SSH root at 8.8.8.8, like so. We hit enter. Key fingerprint, I accept that key fingerprint like that. And it's asking for the password. Let me log in with this quick password, and bam, I am going to be logged in to a SSH server on 8.8.8.8. Now, it's usually at this point that you have some people in the class, they're like, am I an accessory to a crime? Turns out you're not. I'm not logged into Google at all. I want you to look at what I did. Okay, if we look at the top, I'm logged into the Honeypot, excuse me, and then I type exit. The Honeypot said the connection to the server is closed, and then it came back and it says your root at localhost. I never left the Honeypot. I never left the Honeypot. As Ghost Shell just pointed out, we are still trapped in a shell. And this is really, really useful because the commands that an attacker would run on a server they think that they've compromised would be different than the commands that they would run on their own computer system. So as soon as they exited out, they think they are on their computer system. And I tried to SSH into root at Google. I didn't SSH into root at Google. I just connected right back in to the Honeypot again. And meanwhile, in the background, you can see that I was able to intercept my password that I typed in Google's server. I typed in not Google's password. So yeah, this is right there. This would show us what the attacker would be doing if they think that they couldn't get anything. This becomes hacker deception inception. The attacker thinks that they've left and they're still in the matrix. So once again, I totally didn't ever hack Google. That's not legit. I don't hack into things without permission. I was just using it as a pedagogical tool to show you what it would look like if an attacker was still stuck inside of this honeypot. So very, very cool stuff. And I'm hoping that you guys are kind of getting to the point where you're like, yeah, this stuff, powerful techniques to be able to detect the attacker's tactics, tools, their procedures, what are the different commands that they're running, what is the directory structure, and it starts to get kind of weird. Like you're like, oh, geez, I shouldn't have gotten those commands from that attacker as well. All right, so we already did the Cowrie lab. Hope you enjoyed it. We're going to do a few more slides, and then we're going to jump into another one. What if the username and host of the attacker was not root at localhost? So it doesn't matter. It's whatever the IP address is of that system. So it would work on localhost. It would work on whatever the IP address is. I just use localhost in the lab because if I have people get their IP address and run it, it increases the likelihood that they're going to fat finger their IP address or put in the wrong IP address. By running localhost, it allows me to make the lab more resilient to students, and it reduces the errors that happen in the lab. Hopefully that makes sense. So pretty cool stuff. Now, quick question for you. Quick question. Hypothetically, this is listening on port 2222. It is not listening on port 22. By default, you can't run Cowrie as root. How would we make it so that Cowrie would listen on port 22, but actually really be listening on port 2222 without reducing the overall security by running it as root? Anyone know? Joff just got it. Port spoof with port forwarding. Camera high five. Well done, you guys. You guys rocked it. You would use that IP tables rule to redirect from port 22 and port forward it back up to port 2222, where Cowrie is listening. Well played. Well played. All right. Artillery. Now, artillery is a tool that's created by Trusted Sec and the fine folks associated with Dave Kennedy. As far as I know, this is one of the first honeypots that Dave wrote, but I'm not 100% certain. Also, a lot of the honeypot and honey cyber deception stuff that we're talking about, like Dave actually implements that stuff in Vision that they use at Binary Defense, excuse me. So it's absolutely really cool. Check out the cyber deception things that they have at Trusted Second at Binary Defense because they have some cool stuff out there. Now, this particular tool automatically opens up honeyports in a number of widely used services like 135, 445, 1433, and 5900 for VNC. Now, one of the limitations of this particular tool is that it will, it kind of gives a fingerprint. Like if you see the system and it's only running 135, 445, 1433, and 5900, it's probably artillery. But you can actually change the configuration to have it be a subset or just one of these ports and these services. We had a question from Tumble. IP tables port forward, you have to make sure your default listening port is not on 22. That is correct. And by and large, I know this isn't like this is security through obscurity. You might want to move your SSH to a different port anyway, like have it listen on, 4231 or something like that. Just because the general skidiots will miss that. And then you can put Cowrie listening on port 22 instead to catch the skidiots as well. So hopefully that answers your question, Tumble. All right. More evil web servers. So we're working on the new web server that Joe just showed you, which I think is really, really, really cool. And it's going to replace a lot of the sections that are built into this course, right? Because we have the ability to actually do site cloning. But I want to talk about some of the other honeypots that are out there and some of the cool things that have been created. Ben Jackson has created this really cool tool called Labyrinth, Web Labyrinth. That's, of course, the name is based on Labyrinth, the David Bowie fantastic movie with Jennifer Connelly. Another great 80s movie back when movies were awesome, not like they are today on that as well. All right. So the IP tables pre-routing, absolutely. Kernel companion, that would do it. That would reroute the traffic from port 22 to port 2222 where Cowrie is listening. So I called it Web Labyrinth. It's really cool. It's built on PHP, which means you can actually lace this with your other PHP products that are out there. It has some really cool features. The first one that it has is it has this spin the wheel of errors. All right. So I want you to think of not just 100-sided dice. I want you to think of, exactly 100-sided dice, not a 20-sided dice, 100-sided dice from Dungeons and Dragons. And every time there's a request that's made, it rolls between 0 and 100. Now, if the error chance is, if it lands on 16, it says 404 not found. If it hits 23, it says 403 forbidden. If it comes as 42, it comes and it says payments required. This is cool because some of the automated crawlers that are out there will be like, wait a minute, every single request I made is coming back with, a full 200 success. That ain't right. And then it'll just give up. With this particular tool, you can actually add in more of these roles to give it different flavors of what would actually happen in a real website when you requested for something that wasn't there as well. The other thing it does is it tells Google if Googlebot or MSN bot is crawling it, it basically says, go away, don't bother me at all. Just basically get the hell out of here. By default, it reads in a text file. And that text file in the default is Alice in Wonderland. And it chooses a random series of words and it highlights those words and it turns those words into directories. So you can see anything that's blue, like hot, certainly, fallen, find another, when, from, for, she, slides, down, the, whatever. If you click on any of those, it opens up an additional bit of text. So it's randomizing what it's actually showing, and it's randomizing the directories based on the text that's provided. One of the problems that I've had with tools like this, though, is security teams not reacting appropriately to these web labyrinth traps actually happening. So how do you get the attention of a young SOC analyst that's just learning their craft? One of the things you could do is you can make it, instead of Alice in Wonderland, you can just feed it a file of a whole bunch of cross-site scripting and SQL injection attack strings. The reason why this would work is it's sending them in clear text, and your traditional intrusion detection system is going to be looking for these like strings that are known attack strings. So you could literally take something from OWASP or snort signatures. And what's going to happen is Web Labyrinth would just grab snort signatures and just randomly make them more links. So the snort signatures are going through, or the script of sneakers. That would be awesome as well. Oh, I like that one. Slight detour. Kudos to you. So now what happens is literally the IDS system is just going to light up like a Christmas tree, because it's just seeing its raw signature file being sent back and forth. And it's gonna freak out, and that's good, because now your analysts are like, okay, we've got 450 alerts from this IP address. I think there's something going on here. I can't quite put my finger on it, but now I have to look at it. So let's talk a little bit about application-specific honeypots. This is what Joe is working on. It's an application-specific honeypot that allows you to clone any website. So you can also put recursive directories or recursiveness in it as well. So it starts to play like a real website for an attacker that's dealing with it. So you have honeypots out there that will mimic specific applications. A good example of this would be Conpot, which mimics SCADA honeypots. Once again, the goal of this is just to blend in with existing servers. If you're looking at SCADA systems that are out there, like a lot of SCADA networks are a whole bunch of like SCADA systems all clustered together on the exact same network segment. You don't have a lot of environments where SCADA is just spread liberally across the entire environment, spread liberally, like tiptoe through the tulips. Nothing like that. It's just they have a subnet that's dedicated to SCADA, ICS, or the cool kids now call it OT, operational technologies that are out there as well. But this brings us to a problem. Anytime that you're running a SCADA honeypot, a lot of those SCADA honeypots, they use the exact same config again and again and again. And a number of tools out there like Nmap or Nessus, they are on to these honeypots. So these are the core values that'll trip your vulnerability scanner and say, hey, this is a honeypot. And Darren Martin did a great write-up of this all the way back in 2015, where he said, if you're running something like Conpot, these are all the values that you need to change so your vulnerability assessment scanner doesn't freak out and say, this is a honeypot. Nmap picks up honeypots as well. So now we're going to do one for OWA. Outlook Web Access. So with Outlook Web Access, this is one of the most sought after systems that any attacker is looking for. And the reason why is Outlook Web Access portal is a standalone Exchange server, and even Microsoft is trying to get people to stop running their standalone Exchange servers. Why? Because they want to move everyone to the cloud. And this is a good thing. I mean, for a couple of years, it was like every other month, there was a new Exchange vulnerability. And every InfoSec professional out there is like, just don't use your standalone like Exchange on-prem server. Just don't. It's bad. Okay. It's real bad. So what this does is emulate that. And for the record, we do in fact still see today a lot of organizations that are running on-prem Exchange. So if you fire this bad boy up, you're going to get some hits. Now, the goal of this lab is to show you whenever somebody is running something like Z attack proxy, it generates a tremendous amount of traffic to the honeypot. And I'm going to talk about what that means more on the flip side of this lab. Once again, boy, we're just hitting the timing, you guys, today. It's been awesome. We have 20 minutes for the lab, 10 minutes for the break. I do the walkthrough. We do the Ask Me Anything at the end. All killer, no filler. All right, so let's get to it. We're going to do the web honeypot lab, and feel free to run a whole bunch of web application attacks against it. I know I am. I think I have to reset one of my instances because one of my applications is timing out. Oh no, I've got an hour 22 left on this. I'm good. I'm doing really good. So I'm going to be able to walk through this lab with you as well at the end. So with that, let's get rolling. Start the clock. right. We are back. For those of you that don't know, that last song was the music of the Twisted Finger. If you ever watch BHIS talking about news, that is the music, the intro and the exit music. All right, so now we got to get my screen sharing. Let me resume share. There we go. Should be able to see it just fine. So I've already started up Zap because it takes a little while for Zetattack proxy to start. But what we're going to do is walk through like the web honeypot lab that we worked on. Really kind of a cool basic honeypot. Unfortunately, this whole thing is going to be replaced with a new honeypot that Joe is working on that he showed you, because I really like the idea of cloning as much as I possibly can. But before we get too crazy into that, I do want to go back into Shodan dashboards, and I'm going to go to images. There we go. And we're going to go back to this port 5900 thing. And we're going to look at a couple of different things. We're going to load the Shodan images. I'm going to load in Shodan itself. There we go. And we're going to do a search on SCADA, just as an example, about why the site cloning functionality is going to be so important. That's just, wasn't expecting that. That's very real. Let's go to SCADA ICS to get away from the pony love. There we go. That's a little bit better. Bronies. So we have a bunch of SCADA systems that you can see here. Some of them are just, water systems. Some of them are just, what do we got? Like generators, KVM switches, HVAC systems, but we got standard SCADA ICS, but we also have SCADA systems here as well, where people are just kind of calling their system straight up SCADA, right? So we have a number of SCADA systems out on the internet that we can actually take a look at, right? Like if I jump over to this one, what is this one? This one is HIG Access AB. This one's in Denmark, and there is a SCADA system. It's in Danish, so I switched that over to English for me. There we go. Saying we got to be running a newer version of Java. That's awesome. But this would be a great server for us to clone, right? It's cloning a SCADA system. And there's a lot of these SCADA systems that are out there that you can kind of play around with. And you can literally point this tool at these different SCADA ICS systems and basically like create your own honeypots. Another one based out of Indonesia. There we go. That one looks good. Nice. Make it in English. There we go. Please log in. And we have these SCADA ICS systems as well. So we can clone these computer systems. And I think that the directory of like the subdirectory level cloning is really important, because the attacker, we just don't want to clone the main page. And that's kind of what this OA portal is that we're cloning is actually doing. It's kind of just one and done, like it's the flat login page, which you would actually expect from an OA portal. But once again, we want to get that attacker to interact with it as much as we possibly can, because ultimately we're trying to waste the attacker's time or as much as we can. And the more realistic that we can make that cloned website look like, the better the time wasting is going to be, and the more tasty it's going to be as well. So we've got our instance up and running. So now let's go ahead and let's start our OA honeypot. We're going to cd into the opt OA honeypot directory. And then we're just going to run a command to kick it off. Just sudo python3 oa.py. Super, super basic. There, now it's running. I'm going to get my Linux IP address. Well, let's give it to us. That's right there. So I'm going to copy this IP address here. And we're going to surf to it and see what it looks like. All right. Don't want to restore. I'll paste that in. That is not what I wanted. I wanted to do this, paste. There we go. Oh, I wonder if I still have a firewall running. Interesting. All right, let's go ahead and take a look at it. Let's go here. Oops, wrong one. Let's get to our Ubuntu command prompt. Don't have anything in IP tables. That should be our port. Let's try it again. This time, let's try it. I wonder what I did wrong here. Is it the NAT? I shouldn't have any IP tables rules. Had to start and restart the script. What script? Oh, let's try flush. The Python script didn't start for you guys? I wonder if it's the, let's do this. Minus T nat. Go see if that takes care of it. There we go. It was my nat rule chain. All right, so there we go. I had to purge the nat. So now you can actually see that web page, and I probably didn't follow my own directions. That should be the last instruction in the port spoof lab that I probably just skipped. But here we got the domain, the username, the password. It's just what you would expect to see with a standard OA a standard OA page, actually. So now we're going to go ahead and we're going to launch an attack against this system. Let's go ahead and do an attack on that. And I'm going to open this up so it looks a little bit better. We're going to kick off the automated scan like so. I don't need two HTTPs. There's only one of them that's required for this to work. There we go. And go ahead and attack. And it's going to kick out the jams. All right. Let me pull this up so we can actually see this attack methodology. So there you can see it's actually, well, it already crawled. So now it's going through the full attack methodology. And meanwhile, in the background, if we go to our actual honeypot, you're actually collecting all of the different attacks that are being launched at this particular OA portal. Now, there's actually a couple of different points I'm trying to make with this section. The first point I'm trying to make with this section is web attacks are not stealthy, okay? It's not an attack strategy that doesn't generate a crap ton of traffic. It generates, as you can see, a lot of traffic. It's one of the frustrations that we have for some of our customers whenever we do web application security assessments, where we successfully break in and the customer is like, there's nothing we could have done. You know, BB King came in and just kicked ass, and there's nothing we could have done at all. It's like, no, look at your logs on your web server. And we show them the logs, and like, it looks like this absolute train wreck of attack strings. And the customer's like, yep, nothing we could have done at all. No, they're very, very noisy attacks. Like, there is a lot of gibberish that is being sent into your web server that should generate just a lot of logs. And ideally, you want them to attack another web server. And if you're cloning an OA web portal, or if you're cloning a SCADA ICS system, these are going to be the systems that they're going to go after first, right? These are going to be the ones that they really want to nail down, because it's going to be, odds are it's not patched, especially if you have one, just for the record, that comes up and it says, hey, you've got to be running this particular version of Java, and it's actually telling you best resolution for your website. That's a little bit nuts, right? Because if I'm an attacker and I see something like this, like BAS SCADA systems, and I can log on via HTML5 or log on via Java, damn, that's crazy, right? Like that's the goal. You're going for that, right? Now, I want to talk a little bit about the logon Java, which I'm totally not going to do, by the way. But that's actually important. So this class used to be taught by another organization that shall not be named. And we had to kill it because I wasn't allowed to teach the course because I was teaching another one of their classes that just so happened to be their top selling class that they ever had, but we won't get into that. And I had another person teach this class for a very large Fortune 10 company. And one of the labs was we created a malicious Java applet that as soon as you ran it, it basically took over the attacker's computer system, which I'm just going to say, pretty badass lab all told, because we backdoored existing Java applets for it to work. And with this lab, one of the students in the lab was like, well, this is stupid. No one's going to run this because it's an old version of Java. They clearly missed the entire point. I always had this vision of my head like Drax the Destroyer in the Guardians of the Galaxy, where like nothing goes over my head. I would catch it. I'm too fast, right? It's like, so let me get this straight. An attacker coming at your environment is going to see an old Java applet, and the attacker is going to say to themselves, I'm not going to use that because that's old. That is literally what attackers are looking for. They're looking for old stuff, number one. Number two, I spent like 5 minutes on Shodan and I found an incredibly out of date computer system just sitting out there, right? This isn't something that's rare. It's not like, well, you know, this system's a little old. We wouldn't expect that to be on the internet. No, the internet is literally stuffed to the brim with ancient software. In the comic book that we're working on, The Future Is, one of the things about this comic is you're going to literally see technologies from today in that comic book that is set in the future. Because to be honest with you, like the future is completely based on legacy technologies. Can someone find the XKCD comic of the technology stack? Looks like a bunch of blocks stacked on top of each other. And it's like technology stacks. All this new technology is based on a bunch of old technology. If someone can find that, because there's no picture that more accurately represents the internet than that XKCD comic, because literally the internet is completely stacked on top of ancient decrepit technology. So if you're going to emulate something that the attacker is going to go after, emulate that ancient decrepit technology, because they're going after it. Whether it, there it is right there, dependencies, right? It's just, this is just awesome. Modern digital infrastructure project some random person in Nebraska has been thanklessly maintaining since 2003. And that name of that project is OpenSSL. Just to be honest, we're not pulling any punches. That's it. So we're seeing all of these things constantly on the internet. So pretty cool. Like we're going to try to up the ante on this so it gives you the flexibility so you can mimic any of the technologies that you want that is out there as well. All right, so let's talk about attribution. We're going to talk a little bit about legal issues, and then we're going to wrap up for the day. So sometimes there's this really big disconnect between what people think is legal and what is actually really legal. And some of your assumptions are pretty well founded, right? Others are just straight up wrong. So we're going to go through some cases. The first case is Jerome Hackenkamp versus the United States of America. This is a fascinating case for a wide variety of horrible reasons. So a little bit of background. So Jerome Hackenkamp is going to school at a university somewhere, right? And that particular university systems administrator gets contacted by the FBI and they're like, hey, we're seeing attacks against like PayPal and these sites, and it's coming from IP address space associated with the university. Fine. So the systems administrator decides to go hunting to try to find what system on the network might be doing this. And it's able to track it down to seeing this, like the system running these attacks, but the IP address of that system changes fairly frequently. So whoever's running the attack has enough technological savvy, moxie, if you will, to be able to change their IP address at regular intervals. So far, so good. There's no way that this is going to end poorly for said hacker, but stick with me. So the systems administrator goes to the network closet and finds out that the IP address of that system constantly goes back to the exact same MAC address to the same switch port on the exact same room over and over again. So while the attacker thinks that changing their IP address is pretty crafty, which it is kind of, the attacker knows nothing about changing their MAC address, and they don't know anything about content addressable memory tables. and what those will show. So the systems administrator calls up the FBI and says, yo, FBI, I think I've got your guy. I think I've got the room that this particular attacker computer system is coming from. I'm going to go into the room and confirm that this is in fact the computer system that's launching these attacks. At which point the FBI says, no, God, no, do not do that. Let us get a warrant and we will show up on site and then we will go into the student's room. Systems administrator hangs up and is like, screw that noise, and decides to go right to the student's room, have the door unlocked by an RA, and enter that student's room. So stop right there. This is a dormitory. So if you're in a dormitory, do you have a reasonable expectation of privacy for like the university never ever coming into your room without permission? What do you have? Yeah, no. You have no reasonable expectation of privacy. All right. And the reason why is because if you ever look at a lease for a university dorm, it has statements in there and stipulations that say that they can come into your room anytime they feel like it, because they might have to do something dealing with the safety of a student. They may have to do maintenance in a room. So they have those clauses that they can come into the room for the safety of the students and the safety of the university. Okay, now I don't know if that's legit, but I know it's actually held up in courts a number of times. I'm going to come back to this with a personal anecdote a little bit later. So moving forward with the story, systems administrator sits down at Jerome Hackenkamp's computer system and logs in with the default credentials for people that are logging on to the university network with a user ID of temp and a password of temp. Yep, that was the hacker's user ID and password. Got onto the student's computer system and then checked the IP address, checked the MAC address, and verified this was in fact the computer system that was launching the attacks, logged out of the computer, walked out of the room. Now, was the evidence the systems administrator gathered admissible in a court of law? You got no, nope, nope, not at all, nope, no. Ha! Shows what you all know. You're all wrong. It was admissible in a court of law. The judge in this particular case ruled that due to the exigency of the circumstances, which means urgency, and the possibility that the attacker could possibly destroy evidence, it was okay for the systems administrator to do this. And also, Jerome Hackenkamp signed a document saying that the university could come into the computer system, or sorry, into his room for the safety of students and the safety of the university. Also, the systems administrator wasn't acting as an agent of law enforcement. In fact, the exact opposite. Law enforcement specifically told him not to do that thing that he did anyway, right? All right, so now we're going into what happens after this. So Jerome Hackenkamp was represented by the EFF, by Jennifer Granick, who's one of the best like IP internet security lawyers on the face of the planet. She's absolutely amazing. And he fires her. And Jerome decides to represent himself in court and spent months in jail when he probably shouldn't be spending time in jail, because a competent attorney could move the case along and all those different things as well. Yeah, I wouldn't let him off because look at his name, Hackenkamp, kind of like Hackenkamp, right? So there's a case right there. Next case, Susan versus Absolute Software. This one's a little bit more fun. Susan Clements Jeffrey was a substitute teacher at not a university. She was at a high school. One of her students comes up to her one day after class and is like, yo, do you want a dirt cheap MacBook Pro? I've got one that fell off a truck. So Susan Clement Jeffrey sees this deal and is like, well, hell yeah, we want to do that. That sounds like a good idea. How could that possibly ever go wrong? Turns out, spoilers, it did. See, Susan Clements Jeffrey met this student, and I'm not making this up, at a school bus stop. The student sold the computer to Susan Clements Jeffrey for something like $50. Susan Clements Jeffrey took this computer, which, surprise, surprise, was stolen from another school, home and immediately started using the computer to communicate and start cyber sexting her boyfriend. Now, this software had Absolute software installed on it, which is very similar to like LoJack software for computer systems. And law enforcement and Absolute software and members of the university started taking pictures of Susan Clements Jeffrey in various states of undress and sexual activity. Whoa, whoa, whoa. Susan Clements Jeffrey finds out about this, and of course, she is none too happy about this, and she decides to start suing people. Now, Judge Walter Rice in this case ruled the following, said, it is one thing to cause a stolen computer system to report its IP address or geographical location in an effort to track it down. It is another thing entirely to violate federal wiretapping laws to do so. See, Susan Clements Jeffrey did not own that computer system, but Susan Clements Jeffrey did still have a right to privacy on that computer system. And notice how Judge Walter Rice creates this bright, shiny line for us. IP address and geolocation information. In DoD space, and when I'm working with the intelligence community, we're constantly talking about signaling versus content data. We can get signaling data for adversaries overseas. Where we get into some weird things, we want to get access to content of that data. Many times we require many different types of warrants, FISA warrants as an example, to actually start getting access to content. And this actually makes sense. Let me give you an example. Do you have any right to privacy for TCP/IP header information? All the packet headers for all the packets coming and going out of your network, do you have a right to privacy on that? Okay, let me reframe that. Do you have a right to privacy for what's on the outside of an envelope of a letter that you're sending a friend or a family member? For those of you that were not born in the 70s, 80s, 60s, or 50s, an envelope is what you get in junk mail. No, even if you encrypt it, it doesn't make any difference. There's still going to be TCP/IP header information that's there. So when you're looking at this information on the outside of an envelope, when you're looking at TCP/IP header information, this is information that its very nature has no privacy. You have to give this information freely to the public so your letter gets routed properly. You have to give this information freely to the public so ISPs can route your packets properly. That's signaling data. Content data is the contents of that email. That's that TCP/IP packet, or the contents of an envelope, right? It's what's inside that is actually private as well. All right. So next one, reflected attack. Now I like this one too, because we're trying to kind of set the stage, if you will, just like a little bit. So we can look at like some like real world attacks about attackers and what we expect them to do and not do. All right, so let's get started. 1999. This may seem old, but trust me, in the world of the courts, this is brand spanking new, especially with the current courts that tends to go back upwards of around 300 to 400 years for decisions. Okay, so 1999, real recent. Okay, so in this particular situation, E-Hippies Coalition was a bunch of people that were fighting against capitalist organizations, right? I mean, their names were E-Hippies. What do you expect, right? So they were launching DDoS attacks against the World Trade Organization. Connexin, as a hosting provider, went through and redirected the traffic directly at the E-Hippies web server. It was a different time. Just stick with me. They actually had a web server and they crashed that web server. The E-Hippies did not show up to court to say, oh, well, Connexon crashed our web server with the DOS traffic that we created against the World Trade Organization. The attackers aren't going to do that. Like, they're just not going to show up and be like, Your Honor, we're criminals. But they criminaled us, and we don't like the double criminaling thing, and we want to hold charges against them. That's not how it works. Speaking of criminals doing criminal type things, Wolodeck Botnet. This is all the way back in 2010, which once again, incredibly recent for judges out there as well. So this is a civil lawsuit, and it was an ex parte injunction. This means that the party the injunction is against is not present. In short, the judge didn't expect the people that were running the botnet to all of a sudden show up in court and defend their rights. So working with the United States Marshals and the Secret Service and Microsoft and a bunch of other organizations, they took multiple different measures to degrade the overall botnet. Now, because this was Microsoft, they actually gained access to the computer systems and deleted the botnet. Now, if you look at almost any law out there, almost any law in any country, gaining access to somebody else's computer system without permission is illegal, boys and girls. It is absolutely verboten. You are not allowed to do that. Somehow Microsoft, with an ex parte injunction, did. Now, what would be the possible legal standing on an international law perspective to be able to pull this off? All right. I like that. What if hippies were using Cloudflare? Just kidding. Good point. Well before Cloudflare came out. So if we're looking at what actually, from a legal perspective, international laws, getting to pirates, yes, we're definitely getting to that. Specifically, we're looking at maritime laws. So sticking with the pirates idea, let's say I've got a boat. I've got a boat with my flippy floppies, right? So I've got this boat, and let's just say that Ryan steals my boat because he's a scurvy pirate. All right. So he steals my boat, and then he's rolling around in my boat as a pirate. He's got the hat, he's got the cannon, he's got the sword, and he decides that he's going to attack Brian. Now, Brian's a badass, and he sinks my boat that Ryan pirated. Do I have a legal claim against Brian for sinking my boat? Oh, no one's answering this one. Anyone? Can I sue Brian? Nope, I can't. Because as soon as my boat is taken over by a pirate, it's no longer like my boat. And pirates are one of two groups of people that you can open fire on in the open seas without an open declaration of war or warning. What are the second group of people that you can open fire on without a declaration of war or warning? Anyone know? You can sue the pirates. Lawyers? No, not lawyers. Wasn't expecting that one. Not terrorists, not hippies. Human traffickers, slave traders. Now, some of you will be like, well, that's old. There's actually more slavery in the world today than there was back in the 1830s. So that's cheery. But yeah, you can open fire on slave traders and you can open fire on scurvy pirates. Remember, pirates take a shower every Saturday, whether they need it or not. All right. So look at your warning banners. Your warning banners are going to help establish kind of what you can do and really establish what it is you're going to do. And if you ever get to a court of law and it's like, look, Your Honor, we said that we were going to track their geolocation. We were going to check their patches. We're going to check their configurations. We're going to get their user ID because we do that under our normal security business practices to protect our network. That's going to put you on some really solid legal footing whenever you're trying to do attribution, because it's not something that you're doing to a hacker indiscriminately. You're doing it to everybody systematically. And that's fundamentally different, right? If you look at OpenVPN scripts can execute arbitrary Python and PowerShell and Bash on the systems that try to execute those OpenVPN configs. So you can literally create an OpenVPN config that executes like 10, 15 commands and dumps those results back to you. And that can be used for attributional purposes as well. So if we're looking at all of these types of things, I want you to think a little bit about intellectual property and what people do. Callbacks. Microsoft was free and clear with the WalletX botnet, but also think about it. They do software updates. Those software updates are talking back to the Microsoft mothership like all the freaking time. Think about licensing, Microsoft Genuine Advantage, tracking software and phones. Whenever you're trying to find a good cup of coffee using Google Maps is tracking where you are. That's what they have to do, right? That's literally what they do. Like, but it happens all the time, right? They're tracking you to get you to the coffee shop, but they're also tracking you and sharing that information with Google. An example of this would be, do you remember that Google got in trouble because of the Google vans? They had these vans that were driving around with Google Street View, and they were collecting all the wireless information. And in the state of California, Google got into big time trouble for harvesting wireless information. This was a big deal. How did Google get around that? Did they just stop and say, oh no, we're breaking the law, breaking the law? Can't do that. Dun, 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 dun. Nah, they realized instead of using vans to collect wireless and geolocation information, we'll just grab Android users or anybody that's using our apps, and we'll grab wireless information from them. Just pulling it from the phones, right? So what we're talking about isn't hacking per se, but we're actually talking about doing is using the existing technology stacks that are out there, but using them for the purposes of attribution. So if we ever have to go to court and the judge is like, you know, what do you have to say for yourself for hacking or tracking this attacker? And you're like, Your Honor, I'm using the exact same APIs that is running on your phone 5 times per second by Google. And by the way, he agreed to run this because we had a warning banner. We had a EULA, and he accepted the EULA, which said that we would do that. We're getting really super easy for trying to get around many of the legal issues that are out there. So last slide before we get into Ask Me Anything, how can this go wrong? Mistakes or unintended consequences. Number one, easily accessible malware. Don't make your malware super duper easily accessible. Tomorrow, remind me. I'll tell you a story about a customer of ours that made their malware super duper easily accessible for attribution technologies. Full attack on an attacker's IP address, getting into Venom and starting to do Venom level attacks. Don't do that. That's not going to be helpful to you or anybody anywhere. We don't want that to happen. Crashing an attacker system. While cathartic and it sounds like fun, you might be crashing like an X-ray machine from General Electric. You don't want to do that, right? Persistent long-term access without a warrant. We're going back to the options, right? Attribution, annoyance, and attack. We talked about annoyance and how we can mess with the attacker's day. We're now moving into this attributional space as well. So some hallmarks of legality before we get to Ask Me Anything. Discuss. Going to a class like this is the opening of a discussion. You're learning about a topic. Document what it is that you're going to do. Develop that plan. Consult and talk with others. Don't hide what you are doing. If you are hiding what you are doing, it shows that you think what you're doing is wrong, and the courts will use that against you. And finally, don't be evil. Don't crash systems. Don't persist on systems. Don't go through the browser history of an attacker or violate their privacy, because that can come back to haunt you. Now, tomorrow I'm going to tell you the story about a European beverage company, and then we're going to talk about what it looks like to have a conversation about a law that didn't get passed. This is a law that I had some feedback into, didn't happen, and we're going to talk about it when we get there. All right, so what do you have for me? We are now officially in the Ask Me Anything section of the course. What do you have, folks? Jägermeister? No. A while ago, you mentioned that you'd have some people write software automatically change Cowrie. We're working on that right now. It is, in fact, still being worked on. That is part of the interns pool of, you know, updating port spoof, updating Cowrie, or updating the web cloning stuff, and then also working on that as well. Malort, yes, that's it. You nailed it. I'm joking. God, that stuff is awful. Wait, what the hell do you drink Malort with? Is it good in anything? I mean, I don't drink alcohol anymore. Completely stopped a number of years ago, but Malort, that'll drive you over the edge and be like, I just don't need alcohol in my life. When am I coming to New Zealand? Not soon enough, dude. I would say in the next couple of years for sure. Have it with some fava beans and a nice Chianti. No, it would ruin all of those things. Is there a course at Anti-Siphon that addresses pen test strategies to counteract active defense cyber deception? No, there isn't. However, I think I should add it to this class. Problem is I got to cut some things to get that added in. We do have a pen testing class. I don't know if you heard, but Tim Medine is joining the Anti-Siphon security training team, and he's creating the level 2 pen testing course. I've got intro to pen testing. He's going to have the second part of that class. So I'm pretty excited about that. Yeah, Tim did leave the organization that shall not be named. which we can do without that anyway. I know yesterday I said Rita was changing. Does this mean Rita section for 504 will go through a huge overhaul? Yes, it will need to go through a huge overhaul. But I'm still very, very tightly working with Josh Wright. We will get that updated and get that installed on the VM for Sans 504. How can I test my skills so I know what certs to aim for? You need to get set up with the MetaCTF cyber range. So check that out. It's like $30 a month, and it will show you tomorrow what it looks like. If you guys want me to, I can give you a tour of MetaCTF. But we're going to be doing some cool stuff. Like I said, with the cyber range is going to be a big part of our entry level certification on that as well. What is the best thing a company to do without adding new tool or service to improve the security of that company? Turn on turn on app locker, and turn on app locker for just directories. So it restricts all the programs to execute from the Windows directory and the program files and program files x86 directory. And the reason why is that'll stop like 98% of the drive-by downloads that hit your organization as well. If you're the type of person who doesn't like coding because of the $1,000 stare looking at IDA or code block, does that limit how far you can go? It absolutely does. But like I said, use AI, because most of the crap that you want to write for scripts and things like that, it ain't that complicated. And AI, if you can communicate it effectively, block by block by block, it can write up that code for you fairly quickly as well. Tumble, is the Black Friday training program for the, so they're talking about the on-demand bundle. Can I get my screen back? Can someone share back with me?
Do you want me to get the link? It's
I
still
guess,
live.
you know, it's one of those things. How do I put this? We do this every single class, right, Megan? But the number of people that
Yes,
take us up on it,
every single time.
it's pretty low. So here's our course catalog. Let me go to on-demand training. So for $1,500 a year, you get access to every single on-demand class that Anti-Siphon has, and you get access to them on mobile, and you get access to the full cyber range for $1,500 a year. That's Megan, what did we decide that was? Do we decide that that's 95%?
It's like a
off?
93% off. It's like
Discount.
some crazy.
So if you
amount.
want all the training that you could possibly get your hands on, Megan just shared that link out. Like I said, we get like 3 or 4 people that sign up for it. It's pretty
Yeah.
rare. But it's there. You can sign up for it. You can do that. But yeah, most of our classes are about $575. And it's like the $1,500 is like 93% off. For corporate subscriptions, that is the corporate subscription price. And we do that as well. So if you're interested in corporate training, we have that too. Do all my pen tests at BHIS do app pen testing and network pen testing? Yes, you need to be proficient at both, but usually you're going to specialize or one or the other. Whenever we do a network penetration test, there's always a light level of application security testing associated with it. But it's not in-depth burp level attacks against their web servers. It's whatever web checks exist in the default configurations for tools like Nessus and Nuclei for looking for SQL injection and cross-site scripting. So it's a quick once over for web apps, but it's not super in-depth on that as well. And in the intro to pen testing class, that is something that I go into a lot of detail on that as well. Is there such thing as a pen test mentoring at BHIS for students? No, there is not. And the reason why, and I just want to be completely honest about this, is if an intern or somebody that's just mentoring and shadowing, I need to do full background checks for all of my testers. I need to vet them. They need to be under my insurance. They need to be all of these different things. And customers get super duper duper uncomfortable when you have just random interns running attacks. So sorry about that. But yeah, $1,500 is less than paying for 3 of our classes. And it's literally everything we have. So you do need to check that out. It's out there.
And you get a year of the cyber range.
And you get a year of the cyber range with our certifications as well. Megan just shared out my intro to pen testing class. By the way, I am teaching introduction to pen testing at Wild West Hacking Fest. And it's going to be taught in my barn here in South Dakota. There are virtual seats available. I think I only have like 10 more seats available live. But if you want to take it virtually, I take as many people as I can virtually. So check that out. We'll get that class link up here in just a second, but it is also at Wild West Hacking Fest. All right. I like using Tailscale to manage a bunch of servers. We have a security automation class. Where is our automation class? This is by, where is it? It's by Ralph. HackerOps, by Ralph May. This particular class gets into that level of automation that you're looking for, and Ralph does all the automation for us as well. Yeah, and you get the free cyber range. Like, it's stupid. It's probably more than 93% off. But you got to understand, like, what is the goal of anti-siphon, right? So the goal of anti-siphon is to provide affordable training for as many people as we possibly can, number one. Number two, it's creating an equitable pay scale for the instructors. I know this sounds weird, but many of our instructors make as much, if not more money teaching for anti-siphon than they do for other organizations. I won't say who. And that's because some of these organizations, and there's many of them, have like a 93%, actually it's more than that, it's a 97% profit margin. So when we're looking at what we want to make for our instructors, what we want to make as instructors, we're doing just fine. And what we're doing at Anti-Siphon is we're covering our costs, is what we're trying to do. So that's how we do it, because we don't give a shit about making a ton of profits. We're just trying to do cool shit with cool people. Yes. And our pay classes also have a percentage that goes to charity of the instructor's choosing, or more accurately, an open source project. See, there's a lot of organizations out there that charge a crap ton of money and they don't give a single flipping dime back to any open source projects. And in almost any security class that you are going to attend, they're using just tons of open source projects that other people are writing. And one of the things that we find very, very, very disgusting is using a bunch of open source projects and then charging a just crazy amount of money for teaching people how to use these open source projects and then not giving a dime back. So 10% of all of our different classes, the instructors give us an open source project and we contribute back to those projects as well. Brand X, I don't know which one you're talking about.
No idea. Moving on.
Yeah, moving on.
Is there a listed instructor base? Yeah.
Yes, yes, that is something that we're working on the new website, because so many of our instructors are actually in the trenches doing this on a day-to-day basis. They aren't full-time instructors, right? They're pen testers for BHIS, they're pen testers for Red Siege, they're out there. No, it's not 93%, it's 97%, 97%. All right. So when we're looking at like these open source projects and what we're doing, years ago, like somebody that's like a grandfather to me is Stephen Northcutt. And Stephen Northcutt once told me, if I find out that you're just teaching and you're not actually doing what you're teaching, I'm going to end you from ever teaching for us again. And I took that to heart. So I continued to pen test. I started up a company. I started running all of these different things. And I think that that like guiding principle is incredibly important for any organization that does security testing or teaching. You shouldn't have people that are just full-time instructors, period, full stop. I run a pen testing company. We do 700 security assessments per year. I run a training organization. I run a product company with Chris Brenton for doing network threat hunting. We have all of these things, and I'm a barista now, I guess. But if you're looking at Bo Bullock is doing cloud pen testing. If you're looking at Ralph and automation, he's in charge of automation at Black Hills Information Security. If you look at Tim Medine, he's running a pen testing company in Red Siege. You need to make sure that you're taking classes from people that are in the community doing stuff and contributing in the form of webcasts and tools, because their shit ain't stale. It's absolutely fresh shit. I don't know. My analogy just completely blew up in my face on that as well. The drop on the coffee shop. Yeah, we've got a coffee shop.
Did you see the, do you think war shipping, did you see that question? Was up.
War shipping? What's that?
It says, do you think war shipping, think PWNI Express or PWN Plug, things
Dropbox.
like.
Yep.
Okay.
That's cool. I know what they're talking about. A lot of the things that you can get at Hack 5 shop, which, you know, shout out to Darren and the team there. Yeah, we use those things all the time. We actually have some boxes or some blog posts on creating drop boxes for pen tests as well. Do we hire any junior mid-level pen testers? We do. We don't have any positions at the moment, but Q4 is coming. Brace yourselves. Tumble said, years ago when I was first getting into InfoSec, it was very difficult to get past the initial hiring walls. BHIS anti-siphon after countermeasures has greatly contributed to my education. And I'm really hoping that the certification helps that too. Because we're trying to give you something that you can take and you can put on your resume and you can say, look, I am certified anti-siphon. We were calling it ACE-T. I think we're going to rename it to anti-siphon level 1 or anti-siphon core on that as well. Do bad guys use oh my god cables or rubber duckies against companies? Usually no. Like it's very, very rare that you see an implant, a physical implant used by a real life attacker. And it does happen, but it's very, very rare for them to do that. And the only places where I've actually seen that used legitimately is hot nation state on nation state action, where people are gaining access to companies or they're gaining access to facilities predominantly overseas to get that type of persistent long-term access out there as well. What do you look for when hiring a red teamer and pen tester? Just certs or experience, hands down. If you look at most of the testers at Black Hills Information Security, especially the ones that have been here for a long time, a good number of them won cyber range competitions like CTFs, whether it's DEF CON, whether it's counter hack or something like that. And that's part of the reason why we've created Meta CTF. If you want me to tomorrow, I can talk about the hiring process at BHIS, but it begins and ends with the access to the Meta CTF cyber range and solving challenges and then doing a write-up of your capability to demonstrate your ability to communicate effectively out there as well. Yeah, doing John's class. That, yeah, and it's been awesome having Brian on the team. By the way, it is incredibly helpful. We have all these people that are nerd herders that are getting started in security, and we hire a good portion of nerd herders. We haven't hired them all because there's a lot of them, but I will tell you, especially like if we have a nerd herder that has the skills that we need, they percolate right up to the tippy top of the resume queue on that as well. Last Starfighter reference. Yes, it's very much like The Last Starfighter. Very good. All right, everybody. I need to get running. Thank you so much. And I'm excited about tomorrow where we're going to come to the exciting conclusion of anti-siphons, active defense, and cyber deception class. And tomorrow we're going to give out some big thanks to the people that make this happen. So with that, get rolling. We'll see you all later.
Have a good night, everyone. Ryan, you can go ahead and kill it with fire, or Yuri, whoever's here.